everybody, welcome to section 9.8 day 4. Now we're going to do the one that we skipped before, writing a quadratic equation from a table. So we've done linear, we've done exponential, now we're on to quadratics. So let's review. A quadratic equation is of the form y equals ax squared plus bx plus c. So this is how your answer is going to look, but you're going to have to plug in, find a, b, and c. All right, so first let's start by telling you the rules for finding a. So to find a, it's 1/2 of the second difference. Okay, a is 1/2 of the second difference. We'll review what that is later. C is actually just the y-intercept. So it's the 0, comma. Whatever that number is, that's going to be C. And then the hard one to find is B. And B we find by plugging in one of the ordered pairs and solving for B. All right, so those are our rules. That's how we're going to go about doing these problems. All right, so let's try number 1. So first thing, we have to figure out, is it even a quadratic function? So we have to see what our change in y is. So let's see, our change in y here is we're subtracting 3. Change in y here is we're adding 1. Change in y here is we're adding 5. And change in y here is we're adding 9. All right, so those are not the same. So let's check the second difference. The second difference is when you do it again. From -3 to 1, we are adding 4. From 1 to 5, we are adding 4. And from 5 to 9, we are adding 4. So now, yes, it is a quadratic function when the second differences are the same. Okay, so let's write our model. We need to find y equals ax squared plus bx plus c. Now, 2 of these are really easy to find. Let's go back and see if I can show you guys the top again. Okay, so let's find a first. A is going to be half of the second difference. So the second difference is 4. All right, so to find a, it's going to be 1/2 of 4. So what's half of 4? Well, that's 2. All right, so a is going to be 2. So I'm just going to write over it, and that's going to be 2. All right, super easy. Half the second difference is a. And then c is also really easy. C is just the y-intercept. So if you look, what's the y-intercept? The y-intercept is 0, comma, -4. All right, so C is just -4. And then the only hard part is B. You guys have to find B. So can I rewrite what we have? So we have y equals 2x squared plus bx minus 4. Right? We already found A, we already found C, now we have to find B. And here's what we do for B. Pick any xy ordered pair you want, but it can't be the 0, comma, -4. So you can't use the y-intercept again. So pick any one of these ordered pairs. To me, the easiest one, pick whatever one looks easy. I mean, to me, 1, comma, 1 looks easy, so I'm going to pick that. So you're going to take that ordered pair, and you're going to plug it in for x and y, and you're going to solve for b. It's not that hard, right? All right, so in for y, we're going to plug in 1. In for x, we're going to plug in 1, and we're going to leave b alone. In for x, we're going to plug in 1 again, and then we have -4. And now all you guys have to do is solve for b. So we should probably clean it up a little. If we clean it up a little, 1 squared is 1, and 2 times 1 is 2. And then b times 1 is just b, and then we have minus 4. And then we should probably add like terms. So we have 1 equals negative 2 plus b. And then if you draw your wall and solve for b, we're going to add 2 to both sides. And look at that, b equals 3. All right, all good. Plug 3 in for b, and that is your linear model. So final answer, y equals 2x squared plus 3x minus 4. All right, that's the lesson. I'm going to do one more if anybody wants another example, but if I were you guys, you might have to rewatch this again or watch this next example. Okay, but I'm going to do a fresh one if you want to see something new. There's not a lot of room, so let's do one on the back. Let's do number 5. Okay, first step. Is it even a quadratic function? We have to check our differences. So from negative 12 to negative 7, we're adding 5. From negative 7 to negative 4, we're adding 3. From negative 4 to negative 3, we're adding 1. And from negative 3 to negative 4, we are subtracting 1. All right, those are nothing, so let's do the second difference. From 5 to 3, we're minus 2. 3 to 1, we minus 2. 1 to negative 1, we minus 2. Okay, good. Second differences are the same, so yes, it is a quadratic function. Let's write down our equation. Y equals ax squared plus bx plus c. Okay, let's find a first. Remember to find a, it's 1/2 of the second difference. So 1/2 of negative 2. And half of negative 2 is negative 1. Okay, so a is negative 1. Good. And then c is also really easy to find. C is just the y-intercept. So c is the y-intercept, which is 0, negative 7. So c is going to be negative 7. Okay, I'm going to rewrite it and see what we have now. So we have y equals, all right, a is negative 1, x squared, plus bx is missing, and then plus c is minus 7. And now we pick any ordered pair we want, but don't pick the y-intercept one. So pick any ordered pair you want. This time I'm going to use this one, 1, negative 4. Doesn't matter. You're going to plug in the x's and the y's, and you're going to try to find b. All right, so in my ordered pair, y is negative 4, x is 1, b is missing, x again is 1, and then we have minus 7. So see, you just plug in the x's and the y's, and now we just clean it up and find b. All right, so if we clean it up, we have negative 4 equals, well, 1 squared is 1, and 1 times negative 1 is negative 1, plus b times 1 is just b, and then we have minus 7. And then let's add together our like terms. So we have negative 4 equals negative 8 plus b. And then we draw our wall and solve for b. So we're going to add the 8 over, right? Add the 8 over, add the 8 over, and it looks like b equals 4. All right, so b is 4. Okay, let me write it. I'll write it out. Final answer is y equals negative 1x squared plus 4x minus 7. Okay, so you found A, B, and C. All right, guys, nice job. I know this is the hardest one, but if you follow the steps, you're going to be fine. It's not that bad. All right, thanks for watching. See you tomorrow to practice.